Hey Jared, this is the equation you sent me, which looks good to me. It doesn't hurt to leave this in exact form, but that doesn't matter. You're gonna have to put it in there decimal to calculate anyway. But quick idea of Euler's method kind of goes like this. So what you have for this question D, you're asked to just look at the estimates and compare them to the actual value, since you have the actual function that is your model, right? So what I would do is draw a little chart. You have your t values and your y values, and I think they told you there was like one bacteria or something like that, and then 1, 2, you're going to 5. So I think you answered this question in one of the previous problems. So you should have an answer here. And I think they gave you, hold on, I wrote this down somewhere. I don't know, it was like after 2 hours there were 4 or something like that. Where'd that go? Okay, but anyway, so you're going to start. So the Euler's method is using that derivative, the differential equation, that'll give you basically the differential equation evaluated for any value of t is giving you kind of the slope of the tangent line there, right? And then this output for y as an approximation for y, right? So you could just kind of do a third column if you wanted, and you start at the same place. You always start at the same place. So if you start here, then the idea is you can find the real value here using your function for y, and to find the estimate. The idea of Euler's equation is to basically, it's just you're finding the output for a tangent line that's tangent at your previous point, right? So if you draw a tangent line at your previous point and it's going to go, I don't know, whatever the curve looks like. All right, so if you draw a tangent line here, this is, well, it's 0 is what they gave you. So if you're here, you draw a tangent line here to estimate the next step. So your line goes like that, and that'll be your next estimate. So if you think, if that picture makes sense, you're using your information from your last point to get to this point, okay? And that would be your estimate there. And then you just repeat that process to get to 5. So maybe that helps to find this first approximation, and or the approximation for when t equals 1, I should say. Okay, so the approximation for t equals 1, basically, so I'll call that estimate y sub 1 here. You're going to get it by taking your first y value and then adding that to, basically you're building an equation of tangent line, so you need a slope. And then you change in your x values or your t values. So it would be this t value minus the last t value, something like that. So that should give you this estimate, right? Which should be, it shouldn't be too far off of the exact value here. So basically the idea is you take your old y value, your old slope, which you get from your differential equation, evaluated at this point, y equals 1, which is what looks like your differential equation just depends on y. And then because this is the step, so that's good because for this problem the step is 1. I hope that makes sense, but let me know if you still have questions.